Section 6.4 is the skill that we need in order to factor and solve polynomials. And so in section 6.4, we're going to look at a number of different ways to factor a polynomial into all its different factors so that when we get to section 6.5, we can solve the polynomials. Now, the most important part of section 6.4 to understand is what I'm writing in the box, the remainder theorem. You're going to have to test to see if certain factors in the form x minus a are factors of any given polynomial. And the way that you test it is if you put a into the polynomial and the answer is 0, or in other words, if you use synthetic division and find out that the remainder is 0, then you know that x minus a is a factor of your given polynomial p of a. That is what we're going to use for the 3 examples today. So if you need to pause the video, write that down. Most importantly, we're probably going to use what's in green. We're going to do this a lot. That's the basic method for determining if a polynomial has a certain factor. Let's look at an example. Is x minus 3, here's our factor, our possible factor, is x minus 3 a factor of this polynomial p of a? Well, from what we did in one of the prior videos and prior lessons, we're going to do synthetic division. So I know that my a value is 3. So I'm going to put 3 in the little box, and then I'm going to put the coefficients 1, 2, and negative 3 in order. And I'm going to do synthetic division on this. Or in the last video, I think I called this synthetic substitution. Same idea. So I'm going to test it. So doing synthetic division, I bring down the 1, I times those 2 together and get 3. I add those 2 and get 5. 3 times 5 is 15, and I add these 2 together, and my last number is a 12. That's my remainder. Well, going back a slide, it says if your remainder is 0, then x minus a is a factor. Since our remainder is equal to 12, then I know that x minus 3 is not a factor of our polynomial x squared plus 2x minus 3. It is not a factor because this number right there is not 0. Example 2. If you understand it, try this. Is x plus 4 a factor of this polynomial? Well, first thing I need my a value. Remember, it's opposite. It's x minus a, so my a value is actually negative 4. So that's what goes in the box. Now, I also have to fill in any missing zeros. I have a 2, and then that's the 4th power. Third, I have an 8, but I'm missing the x squared term. It's not there, so I got to fill in a 0, and then a 2, and then the final 8. I'll erase this. And I'll draw my line. Let's see if this works. Bring down the 2. Negative 4 times 2 is negative 8. I add those at 0. Negative 4 times 0 is 0. I add those. Negative 4 times 0 is 0. I add those. And then negative 4 times 2 is negative 8. And I add those. And I find out that my remainder is equal to 0. Therefore, from the theorem I said earlier, you can conclude that x plus 4 is a factor of our polynomial 2x to the 4th plus 8x to the 3rd plus 2x plus 8. It is a factor. Try this last one on your own. All right, well, hopefully you notice that the a value is negative 5. So I put negative 5 in here, and I've got some missing terms. I've got x to the 4th, its coefficient is 1. There's no x to the 3rd, so I got to put in a 0. And then I have negative 20 is the x squared. I'm missing the x term, so that's also 0, and then negative 125 at the end. So let's see if this works. Is x plus 5 a factor? I'm going to write this in blue. Bring down the 1. Negative 5 times 1 is negative 5. Add them, you get negative 5. Times those two, I get 25. Add them, I get 5. Times these two, I get negative 25. And add them. And last, I take negative 5 times that. And that gives me positive 125. And I add them, and oh, wow, I get 0. Fantastic. So therefore, x plus 5 is a factor of our polynomial p of a. And that is how you determine if things are factors or not. And we're going to need this skill in order to solve these polynomials in just the next section or two.